Okay, this video is about how to do the pots and pans makeup lab, and we'll have a lab test very similar to this coming up. So you need to know how to do the calculation. So first of all, this is about what you would do is you would be taking a hot piece of metal and putting it into some cold water. So what the student did is the student took a calorimeter, which is basically a insulated cup, and so they took the insulated cup, they had some water in the cup, and so they put some water in the cup, and they measured the initial temperature of the water, which was 21.6. Then they took a piece of metal that was really hot, okay, so the metal was 95 degrees, and they put it in the water. Now the hot metal cooled down and the water warmed up until they reached an equilibrium temperature of 28.6. All right, so that's the temperature. The metal cools down, the water warms up. Now what you can do is you can calculate the change in temperature of the water by taking the final temperature minus the initial temperature, which equals 7 degrees Celsius. And we know the specific heat of water that we're using is 4.18 joules per gram degree Celsius. Now, what we're trying to do is we're trying to find the specific heat of the metal. So we want to use this equation that C is going to equal Q. So the specific heat of the metal is equal to the energy lost by the metal divided by the mass of the metal times the temperature change of the metal. That's what we want to do. Now this is metal data. This is the metal table, so we're going to use all metal data. All right, so in order to do that though, we would know the mass of the metal. The student would mass the piece of metal on a balance. The student would know the initial temperature of the metal. They would know the final temperature of the metal. They can take the final temperature minus the initial to get the change in temperature. And then what they would be able to do is they would know that information, but they wouldn't know what Q is, because if you don't know the specific heat, you can't calculate Q with this information. So what you can do though is you can go up and do this. The student could go up and do Q equals MC delta T for the water, and then Q would equal the mass of the water, 100 grams, okay, times, I'm going to run out of room, times 4.18 joules per gram degrees Celsius, times the temperature change of the water, which was I'm running out of room, 7 degrees Celsius. And what you would do is you would get that Q equals 1644.4 joules. That's just doing the mass of the water times the specific heat of the water times the temperature change of the water. And you would get 1644.4 joules. Well, the water gained that much energy. That must mean that the metal lost that much. So you can transfer that number right down there. And then what you can do is you can say, okay, well now I know enough information with the metal data, so I can go C is equal to Q. I can plug in that negative 1644.4 joules, and I can divide that by the mass of the metal this time, 165.2 grams, and I can also divide it by the temperature change, which is a negative 4 degrees Celsius. And if I do that, I get 0.15 joules per gram degrees Celsius. Now, there are 3 more metals that we actually did in the lab, and you should try these 3 here and check your work using the key that I posted along with this video in this makeup lab. And you should do this before the lab test so you know what's going on, because the lab test is going to be the same thing. Okay, that's it with the video.